Howdy, my name is Diego Cansino, and today I'll be doing video assignment number 2 over kinetics, equilibrium, and air quality questions. Okay, howdy. Just before I go over the questions, just real quick, anything in green is kind of like an explanation to help me explain it. The blue is the actual answer. Okay, so for question 1, it says the overall reaction. So adding all the reactions together, we get this with reactants and products. But after canceling out common species and intermediates, this will be our overall reaction left of N2, 2O2, NO, and 3NO2. That's after canceling, so that's what we end up with. Identifying the intermediates and the catalyst. So the intermediates, what we had canceled here in the first equation, it was the NO and the O3 because they both are produced and then they're both consumed within the next step. NO is produced here and then it's consumed. NO is produced and then consumed, and then same thing with O3. O3 is produced here and then it's consumed, making that a catalyst. An intermediate. For the catalyst, there is none because there is just none that is made and then used up. Produced as a product. Because a catalyst would be appears as a reactant and then as a product later on. So the catalyst would be none. For question 3, to calculate the enthalpy change, it's just simply adding up. According to Hess law, it's just adding up all the changes from the different 4 steps. So adding each of the enthalpies together, we get negative 239.9 kilojoules for the total enthalpy change. If we're drawing the picture, so we start here. I drew this. We start with our reactants, and then we go up for step 1, and then we have our product, our first product of NO, and then going up, the activation energy is the highest in the step 2, and that's what I represent here. And then it goes all the way down, produces another product. Step 3, slight activation energy, goes down even further because this is exo, so it's going to keep going down. And by the end of it, the product, since this is an exothermic reaction, it's going to have an energy change that's less than the initial reactant. I believe I said that right. Yes, so it should be below the initial. So since it's exothermic, delta H is less than 0. Which step is the rate determining step? Activation energy is the largest in step 2, so that means step 2 will be the rate determining step because it's based off the slowest one. For question 6, here we just had to equip them in the formula, so we put them in the formula, and then after given the rate of NO, we simply apply it. So O2 would simply be half of the NO rate, so half of the -4 would be -2. And since NO2 has the same rate as NO, it's going to remain the same, I think. Yes, or it'll end up, I think the negatives will cancel out, so it'll be a negative, just a regular 4. For 7, to find the rate law, both of these are doubling. These are both doubling in their concentration. They both go from like 11 to 22. So if they're both doubling simply means that it's in first order. I think quadrupling would be second order. Yeah, so since they're doubling, it'd be first order, so the rate would look like this. It's the same thing as having the 1 as the superscript. But yeah, so K equals this. So for question 8, it's asking the half-life if NO is in excess. So it would be the half-life would be this equation. It'd be the ln2, I believe, the ln2, which would just equals to the 0.69 divided by the k times the no in x's, but I'm not given no and x's and a specific number here, so I just plugged it in like this. So this would be the equation to find out. For number 9, it says, how do you block this smog reaction? Well, the collision theory states that reaction can only occur if collision energy is high enough. So to stop the reaction, there would have to be some type of change, with I suppose, within the reactants, like something like a concentration change, I assume, because that would probably change how they react, or if they're able to react to produce the products, right? So if I don't know, I think if concentration changes, it might change the amount of energy needed, which will stop the reaction. But this was video assignment number 2 over kinetics, equilibrium, and air quality.